Welcome to today's webinar on Oracle EBS security features that you can use now. My name is Phil Ryman. I'm the Director of Business Development at Integrigy, and I'll be the moderator for this e-learning session. Speaker today is Stephen Coast. Steve is the Chief Technology Officer of Integrigy Corporation. He's been working with Oracle products since 1994. For the past 14 years, he's focused on security, auditing aspects of Oracle Business Suite and Oracle databases, and has written and presented on these topics at various national and regional conferences, including OAUG, IOUG, and the National Collaborative Conferences. I'll turn it over to Steve.
So much, Phil. Today, we're going to talk about some of the features that Oracle has been adding to Oracle Business Suite related to security. I picked out a number of features here that are important to your overall EBS environment and how to secure it. These are ones that you can use now. I specifically went after ones that you could implement without a lot of difficulty and really increase and improve the security of your overall Oracle Business Suite environment. So before we get started, a quick background about Integrigy for those of you not familiar with us. Integrigy was founded in 2001 by former ERP consultants working on large implementations of Oracle Business Suite. Back then, people weren't even changing the app's password, so actually we've gone a long way. Integrigy has two sides to our business. One is a set of products that we deliver to customers to help them secure Oracle Business Suite. The first being App Sentry, which is a security and configuration scanner for the Oracle Business Suite, the database, WebLogic, Oracle Application Server. What's very unique about App Sentry is that it scans the entire application technology stack, looking for security vulnerabilities, misconfigurations, and those types of things. To provide proactive protection of your Oracle Business Suite environment, we provide App Defend, which is a web application firewall specifically designed for Oracle Business Suite. The key feature of App Defend is it can provide virtual patching for your Oracle Business Suite environment. So if you're not applying Oracle Critical Patch updates immediately upon release, and most organizations aren't, most organizations are 60 to 90 days after the release of the CPU, that's a large window of vulnerability in your environment. And many of these security vulnerabilities are high risk. People can hack in easily, can do SQL injection, especially if you're on the internet, but also if you're internally. So a lot of those security vulnerabilities are very damaging to Oracle Business Suite, and App Defend provides that level of virtual patching for those and a large number of other security features in order to protect the application. Where a lot of this presentation comes from is a lot of our services work. So we provide on-site consulting for a large number of clients doing security assessments, security design work. A lot of our clients are interested in how to actually improve the security of the Oracle Business Suite environment. They may have compliance challenges. SOX auditors, PCI, HIPAA, may be coming down and saying, well, you need to do this in Oracle Business Suite, which is not typically easy to do because it's such a large and complex application. So we work with a lot of our clients to assess, find gaps in the security, and work with them to actually, how do you meet compliance? How do you actually implement tools like Oracle Audit Vault, Imperva, Guardium, Oracle Database Vault, those types of tools. We also work with a number of clients who actually are implementing Oracle Business Suite to the DMZ. So we work anywhere from doing penetration tests to actually helping the design and implementation of Oracle Business Suite in a DMZ environment. We are backed up by a world-class research team. Integrigy has found more security vulnerabilities in Oracle Business Suite than anyone else out there. So we actively work on securing the application. What is the best way to do it? If you look at the Oracle Secure Configuration Guide for Oracle Business Suite, that was actually written by Integrigy. If you look on page 2, it's actually got Integrigy's copyright notice. So we've worked very closely with Oracle. We're an Oracle Gold partner, so we're very proactive in this space. We give a lot of educational webinars. We're constantly presenting at the major conferences on how to secure Oracle Business Suite. And a lot of this is the product of this presentation here, is we're working very closely with Oracle on doing new security features. How do you actually protect the application? How do you be proactive on this? So enough about Integrigy. Let's kind of jump into what are some of the new security features? What are some of the things you should be doing in the application? Again, a lot of Oracle Business Suite customers are very stagnant. They kind of implemented the application. They're kind of keeping it up and running. They're not proactively working to secure the application. You need to proactively secure Oracle Business Suite because threats are changing. The application is aging. The technology stack is getting older. There's more and more security vulnerabilities found in the application over time. In the last 2 years, there's been over 250 security vulnerabilities in the application. So how do you protect the application? What are some of the things you need to do? And so this presentation will walk through a couple of those, starting with password hashing. We'll talk about the new Secure Configuration Council, and then 2 features that Oracle has added recently, one being allowed resources, which used to be called allowed JSPs, and also allowed redirects. So let's jump into the first topic here, password hashing. A lot of people on the call will probably say, well, password hashing has been around for a while. The reason I've included in this presentation as a new security feature is there's actually been some updates to it, and we also don't see a lot of clients implementing it. We're always doing security assessments. We do about 100 security assessments a year on different clients, and we're seeing a large percentage of those who haven't implemented the password hashing. In addition, there's been some new additions to the password hashing that you should be implementing. Even if you have implemented it, you should now be upgrading that password hashing to get a more robust security enhancement there. So when we're talking about password hashing, what are we talking about? What's the issue with an Oracle Business Suite? Why would you want to implement this feature? Traditionally, out of the box and by default in all versions of Oracle Business Suite, this includes Oracle Business Suite 12.2. So if you've installed from fresh the latest and greatest Oracle Business Suite, version 12.2.8, that still includes password encryption. So the risk here would be, and there's multiple ways you could get at this, but at the end of the day, someone is going to try to get your application passwords. So they'll try to get your end users' application passwords and then log in as those. So if you talk to one of your internal auditors, if I can go in as a developer and get every production application user password for Oracle Business Suite, that kind of blows away your segregation of duties, all those functional application controls you put in. So if anyone can just go in as any account, that's a very significant control risk to the environment, very significant potential security breach. So how might this happen? This is one example. There's many ways that I can do this, but if there's one thing that you're doing during cloning is you're taking your production environment and you're copying it down from test and development. So kind of step one here is I'm taking my production, I'm doing a traditional clone. I might be doing that on a daily basis, weekly basis, et cetera, and I may be copying down to QA, test, development environments. Along with that is all the passwords. So I'm copying down the FND user table. And when I'm cloning the database, I'm copying that there. I'm then opening up that test and development environment potentially to a lot of different programmers, support people, et cetera, that may not have direct database access in production, but in test and development they do. And now I've actually cloned my passwords down to test and development. The recommendation is I'm always scrambling those, but I may not be scrambling those. So those are stored in the FND user table encrypted. Encryption means that I can decrypt it. If something's encrypted, I can actually decrypt it if I know what the key is. And so therefore, the programmer dude potentially can go into test and development, decrypt all the passwords that are the same passwords in both test and development as well as production, get the passwords for virtually everyone in the application, and then log into production with those passwords. So how does this work? What is the issue behind the scenes? So if we now look at the FND user table, the FND user table actually has 2 passwords stored. In the column encrypted foundation password, it's actually storing the end user's password and their username. It kind of concatenates them together and then uses the app's password to encrypt those. But then it's actually also installing, storing the app's password encrypted using the user's password. And it does that for previously functions like ADI. Remember the old client ADI that ran on your desktop with a little Windows program? Not the web ADI, but the old one. So it needed to get this information occasionally. So this is really a leftover from years and years ago when we were talking about client server and other architectures. This was not designed for the web. This was designed for client server and kind of carried forward in the application design. So if you just Google Oracle Applications Password Decryption, you'll find 200-300 notes out there, web pages, people who have described this in great detail on how you can actually write PL SQL code, SQL statements, those types of things to actually if you have access to a test and development environment, you can easily go in and start decrypting these passwords. So this is an example SQL statement. So what I can do is write a little decrypt procedure within the database, and that function then will actually allow me to decrypt the passwords. So this is an example SQL statement. If you want very detailed instructions, again, just go Google Oracle Applications Password Decryption, and it's all out there, very step-by-step detailed. So virtually anybody with ad hoc access to the database in test and development who has access to the FND user table can easily do this. This is just one example. And then I can just take this decrypt password and I can just put in the app's password, because all I have to do is then remember the app's password is also stored in FND user. So if I don't know the app's password, I can still get it. As long as I have a direct database connection and I can get to the FND user table, I can actually do this very easily. And then I just fundamentally then create a little decrypt function. And here I have to be able to create a function within the database, but there's actually 2 or 3 ways I can get around this pretty easily. So I actually don't even need to create procedure system privilege to do this. I can actually get around this, but this would be the simplest way to do it if I'm a developer, those types of things. This is just showing you an example. But again, if you just Google it, you can find multiple notes out there on how to do this. So the difference between encryption and hashing is encryption stores it and I can decrypt something. If I have the key, I can actually get into it. Hashing is different. Hashing is a one-way algorithm that takes a numeric value and then runs it through a mathematical algorithm and comes out with a very long string of digits and letters to actually store something. And then what you do on a hash is to check the hash to see if the password matches. I recalculate the hash, then compare the 2 hashes. So I can never get back to the original value of the hash. Hashing is much more secure. Any new web application in the world is using hashing to store the passwords. If you see someone that has lost all their passwords through a web breach of some sort, they probably stored it encrypted, which you should not be doing. Oracle shouldn't be doing either. But again, way back when this was designed 20 years ago, hashing wasn't that popular. People weren't really thinking through it. Today, encrypting passwords is not acceptable. You must be hashing them. So Oracle has included the feature of allowing you to hash the passwords. And so what this is doing is changing the fundamental way that passwords are stored within Oracle Business Suite for end users. The key here is this is optional for all Oracle Business Suite versions. There is no way this would be enabled unless your DBA specifically went in and did it. We see this even at a number of outsourcers, cloud providers that, oh, yeah, their DBAs are running it. They're still not doing this. So be very careful. Even if you're in the cloud running this at a number of different providers, ask the question, have you enabled the Oracle Business Suite hashing? There is a patch for 11i, and the code is included with all R12 versions, but again, it's not enabled by default. Even if you just do a fresh install of 12.2.8, password hashing is not yet enabled. It has to be done by default. In order to do password hashing, you implement the instructions based in this one MetaLink note, 4571661. Again, just reference that note, and that will give you very detailed instructions. Oracle, over time, has actually upgraded the password hashing. So when we talk about hashes, there's a bunch of standard hashes out there. The U.S. government certifies a number of these, and you'll kind of, if you've been around IT a while, you probably know some of the names. There's MD5, SHA, SHA-1, and then SHA has a number of different versions, SHA-1 and SHA-2. And when we talk about SHA-1, it's a fairly basic algorithm. Quote, it's broken. For this purpose, it's not really broken, but the key here is if I want to make it more secure, I can use a more robust hashing algorithm. And SHA comes in a bunch of different flavors, including SHA-256, 384, and 512. When we talk about those numbers, that just means on how big of a result it returns. And if I want to brute force it, I want to attack it, I want to do something with it, a SHA-512 algorithm is much stronger than the SHA-1. It will take me a lot longer to try to take those passwords and brute force them offline or do different things with them. So even if you have implemented the hashing previously, you most likely implemented the SHA-1 hashing. So when Oracle first released this, the only capability was to hash the passwords using the SHA-1 algorithm. About a year and a half ago, Oracle implemented the SHA-2 algorithms and now allow you to do SHA-256, SHA-384, and SHA-512. We highly recommend you use SHA-512. It's just the most secure. From a performance perspective, the only time this is ever actually implemented or used is when someone logs in. So yes, it takes a few more milliseconds for them to log in, but it's really not noticeable to anyone. So if you're running 12.1.3, 12.2.3, you should be implementing the SHA-512 algorithm. And so what you do is follow the MetaLink instructions and use AF passwd, which then allows you to choose the algorithm, and you should be using SHA-512. If you've already implemented hashing, you need to run the AF passwd again, and now use the partial option. And so what that does is, if you've already changed it to hashing, everyone has a hashed password. Well, now what you do is you tell Oracle Business Suite to use SHA-512. It will not actually change anyone's password at the current time, but every time someone changes their password, they will be upgraded behind the scenes from a SHA-1 hash to a SHA-512 hash. So again, even if you've implemented this before, this is a new feature that came out a little over a year ago that you should then be implementing this. It does require a patch for 12.2.3 and above, and it does require 12.1.3 plus, which is, again, the 12.1.3 baseline plus some of the additional patches. So again, review the MetaLink note. There's also a MetaLink note out there that gives you a detailed SQL statement that will show you if these are hashed. Over time, we have found some problems with the password hashing. So sometimes it doesn't run well. There's been a number of bugs in it over time. So it is best to verify that all your passwords have been hashed. Because what we do is often see at clients that maybe 80 or 90% of the passwords have been hashed when they ran the user migrate, and it said it ran successfully, but it actually errors out on some passwords and doesn't convert those. So be sure at the end of the day, after you run this, that you actually run the verify to check that all the passwords are hashed. And some of them aren't hashed. Open up a support note with Oracle, Atar, and they'll actually help you fix it. Different versions have different versions of the SHA. So again, all versions support SHA-1. So if you're on 11.5.10, you have to apply at least RUP 6, and you can support the SHA-1 hashing. 12.04 and above support the password hashing. But again, the more robust hashing is not available in 11.5 or 12.0. For 12.1 and 12.2, if you're on at least 12.1.3 plus or 12.2.3 plus and you apply the appropriate patches, you can then upgrade the hashing to a more robust hash. And behind the scenes, what's happening is, remember, the FND user table included ZG as the prefix. Now what it'll do is actually include X as the prefix, and XG or XH shows if it's case sensitive or not. And it's actually getting rid of the foundation password and actually just storing in the encrypted user password the hash. So these hashes, if I want to try to get back to the original password, I can never decrypt them. The only way I can do is take that hash and then run every possible combination. And again, millions and millions of combinations. It'll take me days and days and days, if not years, to try to break into someone's password. So these become much more robust in terms of storing the password. So that was kind of an old security feature that is also a new security feature. So hopefully everyone is looking to implement that. Another feature that has been released recently by Oracle is the Secure Configuration Console. One of the major issues we see with most Oracle Business Suite environments that we do on-site security assessments all the time is that, again, this is a very complex application. So when we're talking about Oracle Business Suite, we're not talking about just an application. We're talking about a very large legacy application. It was developed in the 1980s that has evolved over time. It's not the most secure by default. Then we throw on an Oracle database on top of it, and then we throw in different types of web application servers. If you're running 12.1 and prior, it's Oracle Application Server. If you're running 12.2 and above, it's WebLogic. So, and then we're asking the DBAs to actually secure all this. As you can see, there's lots of different potential issues there. It's very complex. If you go through the secure configuration guide for Oracle Business Suite, you're talking about a 40-page paper, that very detailed, very cumbersome to go through and try to make sure that all those items are secure. That's why we wrote our tool AppSentry. So our product AppSentry has been around since 2008, helping our clients secure this. A couple of years ago, Oracle has come up with the similar concept to try and say, okay, yeah, we've noticed that clients aren't securing Oracle Business Suite very well. They're missing a lot of steps. They just don't have time. The DBAs just are tasked with trying to keep this up and running. The last thing on their mind typically is, how do I go through and check all these things? Oh, by the way, I'm patching, we have developers in there. The configuration also drifts over time. So not only may you've not done a hardening initially to make it secure, things are changing over time. So settings may be changed. We find all the time Oracle MetaLink notes that tell you to actually make the application less secure. Oh, if you're having a problem, go turn this off. Go change that parameter. And those parameters may not be secure settings. We find that probably one every couple months, we find a MetaLink note out there. We're like, okay, how did that setting get changed? And we talk to the DBAs and they say, oh yeah, I remember that. I looked at this MetaLink note and it told me to turn that off. Okay, that's a problem. And so that's the reason why you constantly have to be checking your configuration. What is the problem? And how do I do that on a repeated basis very systematically? Oracle's solution is to come up with a secure configuration console. So what they're trying to do is go through the Oracle Business Suite and say, okay, we'll do some of those checks for you. We'll automate some of this for you. So it's very limited. It's only a small number of checks. So it's 18 checks for Oracle Business Suite 12.1.3. 12.2.6 is 24 or 14 checks. 12.2.7 is 24 checks. So Oracle is building on this over time, but it's really geared for the latest version. So it's really intended for 12.2.6 and above, because that's when it was originally released for. And Oracle is now adding in 12.2.7, 12.2.8. They're adding more checks. These checks are not getting backported to previous versions. So you really have to be focused in on 12.2.8 to get the latest and greatest from the Secure Configuration Console. In order to install it, it comes out of the box for 12.2.6 and above. If you want to install it for 12.1.3 and it's only supported for 12.1.3 and above, that you need to apply a patch, and there's a MetaLink note out there. One of the key interesting things is they do bury it. So once you install it and you're trying to look for it, it is under Functional Administrator Configuration Manager, and I'll show you that in a second. So when we look at the Secure Configuration Console, again, 12.1.3 is only 18 checks. 12.2.6 is 14. 12.2.7 is 24 checks. So again, these are some of the more important ones. Oracle has really focused in on kind of, okay, let's help you out, try to get some of the key items here. To give you a little reference here, AppSentry, our product, has actually 300 checks. So we're about over 10 times as many checks as Oracle is doing. So again, it helps. This is a good tool if you have nothing. Definitely highly recommend you implement Secure Configuration Console. But if you want to go more, this is not going to solve every problem for you. It's not going to find every possible security vulnerability, but it will help you get down that path for sure. So if we kind of quickly jump out, and I'll kind of show you Secure Configuration Console here for 12.1.3. So if I log in as this admin, again, you should be using your own named account that has a system administrator, functional administrator responsibility. So again, Secure Configuration Console is here under Functional Administrator. So if I go into Functional Administrator, under Configuration Manager, I will then see the Secure Configuration Console. And then I can easily pick checks to run. Seeing for 12.1.3, there are 18 checks. So an example of one check is checking for the AppleSys Pub privileges. So AppleSys Pub is, again, that default database account that is used by, was originally generated and created for client server. And it's used by a few functions still within the Oracle Business Suite, and it should be very limited. And the password should be changed in 12.1 and above, and should definitely be changed in 12.2. Unfortunately, Oracle doesn't have a check for that. What they are checking is that it has very limited privileges. And over time, one of the issues with AppleSysPub was that Oracle has made it more restricted over time. Unfortunately, what they don't do is remove any privileges. They do, if you create the account, they set it correctly today. But if you upgraded from, let's say, 10.6 to 10.7 to 11.5, a couple different versions there, and now you're on 12.1, the privileges on AppleSysPub may not be correct. It may have an example. There's one view called FND user view that it should absolutely not have, and that was accessible in 10.7. That still may be on AppleSysPub. So this is one of those checks that's checking to see if AppleSysPub privileges are appropriate. So these are kind of just a couple examples of how the Secure Configuration Console works. Again, it's looking at things like the mod security configuration. Is this enabled and active? Have you set up database profiles based on the recommendations that Oracle has done in their secure configuration guide? It's checking for some default database passwords. Again, this is a pretty good check because it's using Oracle database built-in DBA users with that password. Unfortunately, this check is only checking for known database accounts by Oracle with 1 or 2 passwords. So if you should be looking at potentially all other, if you really want a highly secure environment, we recommend that you look for something additional to those. But this at least provides you a fundamental way to check. It's free, it's included with the application, so there's no reason not to use it. But again, it does have some limitations that you should be aware of. That's just kind of a quick overview of Secure Configuration Console. Again, fairly easy to implement. A simple patch, if you're on 12.2.6 and above, it's there. You can immediately go in and start using it. If you're on 12.1.3, it does require a patch to install. One issue we do get with a lot of clients, though, is for those of you who have implemented 12.2.6 or you've actually applied it on 12.1.3, one of the key features here is when you actually do a 12.2 RUP patch or you actually install it in 12.1.3, it actually locks down the system. And so you actually have to go in and acknowledge that there are security vulnerabilities or security misconfigurations and either fix them or just acknowledge them and say you'll fix them later. So it locks everyone out of the system. So we get a lot of clients who are actually doing upgrades and things and kind of get stuck and say, oh my God, we're trying to bring it up, we're trying to do it as automated as possible, and oh, by the way, this is blocking down the system. So this is just something to be aware of. One of the key features here, though, is there is a command line option to unlock and actually acknowledge these and kind of move beyond the lockdown. So you can actually unlock the system if it has been locked down. So if you are doing automated patching, we always include within those scripts, especially if you're doing any of those RUP patches, you can actually include this command line with the -unlock and include that at the end, and it'll automatically unlock. So if you are trying to get patches installed, having them run at night and you don't want to watch them, and then run a manual command when you're done, or if you go in as system administrator, it will then immediately prompt you to unlock. Using the command line will actually get you past that. So that was Secure Configuration Console. Again, a nice feature. It's included within the application, something that you should definitely be looking at as it's free included as part of the Oracle Business Suite. So the next two features we'll talk about are web-based features to help make the application more secure. And the reason for trying to make the application more secure is if we look at Oracle Business Suite, everyone on the call today and every Oracle Business Suite customer in the world is running financials, manufacturing, HR, CRM, and Oracle Student System, and who knows what else is included as part of the 250 modules. Even if you just tell me, oh, no, we're just running financials. No, you're running manufacturing, CRM, Oracle Student System, everything else. Because the way Oracle Business Suite works is when you install the application, you get all the application code no matter what. Even if you haven't configured it, licensed it, or kind of checked those boxes during the install, the code is still there. It is still available. So when you have an installed Oracle Business Suite, you have 20,000 plus web pages running there. You've got partner management, you've got Oracle Student Systems, you've got CRM. All those pages are fully accessible. They may not work, they may blow up at some point, but again, if there's security vulnerabilities or issues in those pages, most often that happens before it checks to see if you actually have configured Oracle Student System. So there's a large number of vulnerabilities, and if you can reduce the surface area of the application, you can make it much more secure. So the threat here is the surface area of the application. I've got a highly integrated application with 20,000 web pages. What do I do about this? How do I actually make it more secure? For those of you who have implemented it in the DMZ, such as like iSupplier, iRecruitment, hopefully you've gone through the DMZ documentation really carefully, implemented Appendix E, which is the URL firewall, and then also what we call the OA Framework Governor, to actually block access externally to JSP pages, servlets, and OA Framework pages. And the way it does it for OA Framework is it blocks it to certain responsibilities. There has been no equivalent previously for internal implementation. So when you implemented iSupplier on the internet, you can block it down to just iSupplier. If I'm just running financials internally, there's no way I can say just turn off Oracle Student System, block all those web pages. So within 12.2, Oracle has included a feature called allowed resources. It's formerly known as allowed JSPs. So they changed the name from allowed JSPs to allowed resources. It is the exact same functionality as it's been rebranded and enhanced over time. So just like you did on the DMZ using the URL firewall, trying to block access to all that surface area of the application, you can now do that also internally in your environment. So this is an explicit list of JSPs within the application and servlets that I'm going to allow access to. So if I'm just running running financials, I'm going to limit access to all those other modules. I'm going to take that 20,000 web pages and decrease it as much as possible. The original release in 12.2.4 was very rudimentary, and I'll show you an example of this in a second. Oracle has definitely enhanced this starting with 12.2.6, and there's actually been a couple more changes in 12.2.7 and 12.2.8. What they're trying to do is make this much more robust and much easier to do. And if you want the detailed instructions on how to do it, it's in the Oracle Business Suite Security Guide. So starting with 12.2.4, this was released. However, it was not enabled by default in 12.2.4 and 12.2.5. Starting with 12.2.6, it is enabled by default, contrary to some of the Oracle documentation. And some of the issues around here is it is a new feature. Not a lot of people are using it yet. So when you enable it, you set a profile option to actually say either allow everything or I only allow certain pages. Starting with 12.2.6, these pages are now stored in the database and they provide you a nice GUI. So with 12.2.6 was really the transition. In 12.2.7, they've really enhanced the interface. It's very powerful now in 12.2.7 and 12.2.8 that I can go in, it's got a nice GUI. The pages are all displayed there. I can actually run some scripts and tools to actually populate the list. Previously in 12.2.4 and 12.2.5, I actually had to go use a configuration file called allowedjsp.com. And Oracle gave me some samples which helped me along the path, but they weren't complete. There's still a lot of tuning around this. So if you're running 12.2.4 or 12.2.5, this is the allowed JSP file. So again, this is a whitelist, and it's line by line of what pages are allowed. This is very error prone, subject to a lot of effort and time to actually try to get this working. But at the end of the day, this is one of the more powerful security features in Oracle Business Suite, and it's trying to eliminate this risk. To give you an example, within the last CPU that was released in October, there were vulnerabilities in a module called Partner Management. You're not running Partner Management. I've actually never met a client who was running Partner Management. But if I had allowed JSPs running, that Partner Management security vulnerability would not have been accessible. Therefore, no one could exploit it. There are some other security vulnerabilities in there that were related to OA framework pages and some standard pages, But again, I've not only reduced the surface area, I've reduced the risk of the application by blocking access to these pages. So with allowed JSP, if it's not in this list, you can't actually access it. And Oracle gave you some financial pages and things like that, but it still requires some tuning, both to allow some pages and also reduce the surface area more. So when Oracle's talking financials, if you're not running fixed assets, even there's fixed assets pages, there's everything in there. So it does take a little bit of time and effort to figure it out. And occasionally, there is some cross here. So we've run into some clients who are running just financials, and they actually had to enable CRM pages to have some functionality work. So this is not a super simple process, but Oracle is giving you the tools now, especially in the latest releases of 12.2, to be able to do it. So what happens if a page is now allowed? One of the complaints about allowed JSPs has been that the error messages aren't very helpful. So in 12.2.4, 12.2.5, if someone tries to access a page, and through no fault of their own, they're just going through menus and responsibilities and picking something and picking a page, and it'll just pop up this error requested resource page is not allowed, versus putting them to a nice page and saying, oh, you don't have access to this, please send a message to the administrator. It just pops up with this very generic, simple message. 12.2.6, a little bit better, but it's just basically forbidden. So again, it's not the most user-friendly feature at the end of the day, but from a security perspective, it is very effective. Starting with 12.2.6, Oracle, prior to 12.2.6, Oracle was giving you these allowed JSP configuration files, which were helpful, but very manually and very prone to issues. Starting with 12.2.6 and very much enhanced in 12.2.7 and 12.2.8, is that Oracle is now giving you scripts that will help you generate the allowed JSP list. So what this does is now starts looking at what's configured in the system, what pages have been previously accessed, and generating reports for you to say, okay, these are the pages that we think that you're using in your environment. And this is very specific. So first, it's disabling inactive modules, and then it's looking at web logs, trying to figure out what's actually accessible and not accessible. And again, back to 12.2.4, 12.2.5, the best way to do this is actually go through and look at what's in the web application logs and try to find things. Logging is an issue here in 12.2.4 and 12.2.5 in that you actually had to go through and pick out, try to figure out, okay, is someone actually getting blocked? What are the issues there? So again, a little bit of error prone, but with 12.2.7, 12.2.8, it's actually much easier. So that's the fundamental allowed JSP capability. Again, this is very powerful, but it does take a little bit of time and effort. Next topic is allowed redirects. So allowed redirects is related to a very specific set of issues within Oracle Business Suite that makes the application more prone to phishing attacks. And what a phishing attack is you get a lot of those eBay emails like click here, or different Amazon, your bank. People are sending out massive amounts of emails that are hackers that are trying to get people to click on a link. And then once they click on that link, even though the link kind of looks good, it will redirect them to a website, and which will allow them to pop up maybe a web page that asks them, that looks just like your bank, but it asks for your credentials, and then they can steal your log on to your bank. That's fundamentally a phishing attack. The key part about a phishing attack is it requires that end user interaction. I need to send an email. And what we're seeing now is very directed attacks against Oracle Business Suite. So hackers around the world are looking for organizations, and they can find out that you're running Oracle Business Suite. And so what then they're doing is finding email addresses at your organization and going after and sending very directed attacks. And this assumes a little bit that you've got access to eBusiness Suite through the internet. Some of these attacks we are actually seeing on that they've compromised your internal network, get your email address, and then they're actually sending emails internally. We've seen that attack. We've seen this against Oracle Self-Service for HR. So there's one organization that we recently implemented our App Defend product for. that they were losing $500,000 a month on people attacking the HR self-service and changing their employees' direct deposit bank accounts within HR self-service, and then redirecting that money to another bank account and stealing that. And for a few months, they were losing $500,000 a month because the phishing attacks were so capable, and they were able to get so many employees. So Allow Redirects is helping to solve that problem within Oracle Business Suite, because within Oracle Business Suite, there's lots of redirects. And what a redirect is somewhere on a URL that I'm going through the application, and if you carefully look at the URL, you see what the browser is accessing. What you'll see actually in there is Oracle is including URLs within web pages that then send you off to either other locations. If you're doing iProcurement, you're maybe popping out to Staples, those types of things. But there's also a lot of redirects within the application. And so if you were designing a web application today, you wouldn't be doing as many redirects. You wouldn't be designing it the way Oracle did Oracle Business Suite. So it's kind of somewhat of just the way that web works, but it's also somewhat of the architecture of Oracle Business Suite. And so these redirects have become a problem, especially around the phishing attacks. So what Oracle has done is to help solve this problem is actually allow you to specifically say what sites may be redirected to. Because what the attacker is going to do is send a phishing email with a nice URL that looks exactly like your URL for your Oracle Business Suite environment, but at the end will redirect them to an external site, which then may have a logon page that looks just like your Oracle Business Suite logon page, and therefore then they can steal your credentials. Allowed Redirects turns that off to prevent that type of phishing attack. And so again, this is not the most critical security vulnerability, but it is actually very capable and very possible, especially in DNV environments, or if they can send emails to internally, because on that, even if I send an email with your internal ERP URL to one of your employees, it will then have an external link that will send them outside your network. So again, very capable, but typically this is a directed attack. And so allowed redirects is just a simple list of exactly what sites that someone's allowed to go to. And so Oracle is limiting it to just Oracle Business Suite itself. And if you're doing things like iProcurement, you would just say staples.com, officedepot.com, and you'd include that short list, and which then prevents this type of attack cold. And so it's been very capable, very functional. However, up until 12.2.6, this was actually off by default. And starting with 12.2.6, it will actually be enabled by default, so you do have to put this in. But it does prevent this specific type of phishing attacks, which we are seeing an increase of. So Oracle Business Suite does pre-configure this already for a number of automatic redirects. So if you're using things like AccessGate, identity management, you're using OBIE, those types of things, it's already configured to already work out of the box. The problem is the configuration is if you are using external configuration items, like you're working with iProcurement and you have to redirect punch out to those external sites, you have to configure those. If you're using Agile, Siebel, those types of things, that highly integrated environment, you do need to put that in. If you've got custom code, because this is working as a filter level, you actually have to put those redirects, those custom redirects in also. This is one of those items that much easier to implement than allowed JSPs. Allowed redirects is, you'll figure out it's not working pretty quickly once you do a little bit of testing in your test environment, your QA environment. And it's pretty easy to set up, and it does give you a nice security benefit across the board. So anybody on 12.2.5 and above, we highly recommend you implement this. Because especially we're seeing this more and more. It's kind of interesting to see. This is the targeted attacks against Oracle Business Suite environments are definitely increasing. One question we always get from DBAs is, how do I test this? How do I know it's actually working? I have to go through and figure out what pages there are. You can actually create just a custom JSP page, and will allow you to very easily test each redirect to make sure you're getting the URLs correctly. just remember to delete this page or make a really obscure name so someone can't kind of find this and use it as a launching pad for redirects out of the box. But again, this one little simple page, you just create this custom JSP page, and it'll actually allow you to make sure and test each of those URLs that you're putting in there that are redirected. Because one of the difficult parts about testing this is every single point I have a redirect, I actually have to go into that code and make sure someone goes through that path and tests it to make sure all these places are working correctly. And every time I add one, then you have to make sure you go back and test. So when I have a procurement punch out, identity management, all those, I need to be testing those whenever I'm making any changes to this. So that was allowed redirect. So again, a very useful feature going after a very specific attack, but that's only available in the latest version of Oracle Business Suite. So I included a couple other features here that Oracle has thrown in along the last couple of years. And so one of the areas is around SSL, Secure Sockets Layer, and TLS, Transport Layer Services. And these two areas are improving the security. So when you go to your bank and you see HTTPS in the browser and that padlock, that's SSL TLS. And the difference between SSL and TLS is SSL is the older version. So SSL was versions 1, 2, 3. TLS is versions 1.0, 1.1, 1.2. So TLS is a successor to SSL. So if you had an older browser and you recently tried to go to your bank was telling you, sorry, you need a newer browser, you need to support TLS 1.2. There's been issues with the older versions of SSL and TLS, so you should not be using those. Everyone should be moving to TLS 1.2. However, the Oracle Business Suite, depending on, especially on what version you're running, has had a significantly older TLS SSL stack. They haven't upgraded it very much, and only recently did they upgrade it to TLS 1.2. And therefore, this does require a little bit of re-implementation. You do need to spend some time actually implementing it, doing a number of upgrades to the Oracle Application Server, WebLogic, etc. However, our recommendation is you should never be doing SSL TLS on Oracle Business Suite. You should only be doing it within a separate termination point, like your load balancer or a reverse proxy. And the reason we recommend you don't use the TLS within Oracle Business Suite natively is that it is an older stack. They don't upgrade it as often. If you do it within your load balancer, such as like a product like F5 Big IP, that is upgraded quite often. Your security team is carefully making sure that that is highly optimized, that you are running TLS 1.2. Your certificates are working correctly. The algorithms, the encryption algorithms going back and forth are highly optimized and perfectly matching the browsers within your organization. So that they spend a lot of time and effort making sure that's done right. Versus if you're implementing TLS within your Oracle Business Suite environment, your DBAs are doing it. They are not TLS encryption experts at all. They're just kind of following Oracle's documentation. It's behind, it's dated, it's not the most robust. So I included this as not as a feature, but as kind of a recommendation that Oracle say, oh yeah, we have TLS 1.2 support now. Our recommendation, you should not be doing it at the Business Suite layer. You should be doing it at the load balancer layer. It's much more robust. Very similarly, there's another feature that Oracle has added recently, is support for what's called HTTP Strict Transport Security, or HSTS. And this enforces a connection when the browser connects to the server. When the server returns this, it tells the browser, oh, only communicate with me versus this secure connection, HTTPS, TLS, just like you're communicating with your bank. Don't do anything else. Don't do plain text. Don't do just pure HTTP. And again, you should be doing this at your load balancer level. Oracle's behind the scenes. If you had implemented TLS through your load balancer as your termination point, it would have already been doing HSTS for years. You wouldn't have to work and spend time and effort patching Oracle and trying to make this work in Oracle. Everything would have been perfectly working and acceptable. So another couple features that Oracle has added recently, And I kind of highlighted a couple of these just to show you differences about where these security features come from. So when your browser talks to the server, there's some communication going on behind the scenes, that information is being passed about how to make the connection more secure, what the browser should be seeing from the server, how the browser should be interpreting what it's seeing from the server. And one of those is called X content type options. And this prevents a very specific attack in that I can kind of put different things in the web application that will then get returned, and the browser sometimes has to guess what it is. If I put no snip, the browser won't guess. It will only use what's passed from the server, because that's what you want. You want the server knows what is returning to the client. And so Oracle included this new feature. However, it was included as part of the critical patch update, not as part of a separate patch. So this shows you an example that Oracle is releasing and including new features within the critical patch updates. So this is just another reason to be applying critical patch updates on a reasonable basis, because you're not only getting fixes for vulnerabilities, you are getting some new security features that are kind of closing classes of vulnerabilities. Another feature Oracle's added in as part of separate patches is another very behind-the-scenes web security feature called the cookie flag set to HTTP only. Another significant risk in Oracle Business Suite is when I connect and sign on to Oracle Business Suite, I'm getting a session cookie. If someone can steal that session cookie, they can sign on as me. They just basically, I don't even have to sign on. If I have the session cookie set up in my browser, the application says, oh, you're already signed on. You're already signed on as Joe. Well, there's a number of attacks, including what's called cross-site scripting attacks, that'll let me steal these session cookies. Very powerful. So if I can send, again, a phishing URL to someone and actually get them to click on a link, I can then potentially steal their session cookies. So this HTTP cookie flag is one way that you can prevent that session cookie from being stolen. This is, again, another patch by Oracle. And again, this is only in 12.2 and above. They're promising the backport is 12.1.3. But we haven't seen that patch out yet. The HTTP only cookie flag has not been marketed, that's probably the best word, by Oracle very much. They have included in some presentations, but there's not many meta-link notes on this one. But again, this is a separate patch that will help prevent this attack. So that's a high level of some of the new security features in Oracle, going from an old feature and then kind of including some of the newest features that Oracle has released. Again, this presentation and webinar recording will be available on our website, and you should be getting it all in email in the next 24 hours with that information. I'll open it up to Phil, see if there's any questions.
Thank you, Steve. Very well done. Yeah, we have a couple of questions here, and you just answered one of them. Was it going to be recorded, and will it be available? And yes, it will be available sometime in the next 24 hours, the webinar I'm talking about. The next question. If you have only time to implement one of these new features, which one would it be? Good question.
Very good question. For us, the password hashing is a very significant issue. That having just encrypted passwords is unacceptable. So if there's one feature, especially for the newest versions of Oracle Business Suite, implementing the hashing is very critical. Because we see so many problems with people going in as developers, getting production level passwords. And if you talk to your internal auditor, they would probably fall off their chair saying, oh my God, that's a possibility. We've spent so much time doing segregation of duties and internal controls. And oh, by the way, anybody can just get everyone else's password. So that's probably the one that has zero cost, very easy to implement, and for the newest versions doesn't cause any problems.
Well, that's a good transition to the next question, which was, are there any known problems with the password hashing?
So actually a very good question. So yes, there are. So the password hashing is available on all supported versions going back to 11i of Oracle Business Suite, including 12.04 and above, 11.5.10 and above, starting with Web 6. Especially in 11.5.10, there were a significant number of problems, especially around add-on products. So if you're doing like ADI, there's a whole list. If you go through the MetaLink note I provided there, there's a whole list of things that also have to be upgraded simultaneously. Those problems don't really exist in 12.2. They're mostly in 11.5.10, a little bit in 12.0, and the early versions of 12.1. But once you've kind of implemented and gone on higher versions, those problems all seem to have disappeared. But in the older versions, there are significant issues that you definitely have to address. And if you go through that MetaLink note, it includes what additional products need to be all patched simultaneously. And then if you look up, there's a couple notes in there about specific issues with either add-on products or within the application itself.
And the next one, we've tried the allowed JSPs, but it required way too much tuning. Any suggestions?
We've spent a lot of time working with a lot of clients on the allowed JSPs. So it's kind of, let's pop back real quick. On the allowed JSPs, again, there's 12.2.4 and 12.2.5 that we saw a lot of clients pick this up initially. And again, this is what you're implementing, this white list, file by file, and you're just listing out the JSPs and the serverless. Very error prone, very difficult to do. Starting with 12.2.7, there is this new web interface that makes it easier. And then they've also added in this Perl script that will actually go through the configuration and generate it for you. We have had some clients who've just decided in 12.2.4, 12.2.5 not to implement it, and they've waited till they've upgraded to 12.2.6 or 12.2.7 to actually implement it. They've seemed to have been more successful. Kind of our answer to this was we actually have our App Defend product that does allow JSPs in a very much more robust way. App Defend does it, you just tell us the module. And so if you're running iSupplier, you tell us ISP as the module name, and App Defend will go through and develop that list for you, and knowing what pages are allowed and not allowed by just a module name, by doing a bunch of different work to figure out that list, that what you're using, what you're allowed, what you've actually got configured or not. So that's our recommendation, is actually App Defend, or really starting with 12.2.6 and above. I think it's much easier to do. But our App Defend product's been available since 2005. We've got a highly optimized algorithm that will actually figure this out and has been doing this for you, and also does it for all versions. So App Defend works for 11.5.10 all the way through 12.2.8. And it handles this much better than we believe Oracle does. So again, two answers there. One is App Defend we think is probably the better solution here, or I would wait for 12.2.6 to actually implement it, because you get a lot more features and capabilities from Oracle to help you do it.
Well, thanks, Steve. I think that wraps up the questions for the day. And again, I want to thank everybody for participating with us this afternoon. And be sure to tune in again for us next month. December the 6th will be our next webinar, educational webinar. So until then, have a great day and a great rest of the week. Take care.